The Full Circle Podcast. Compelling interviews and incredible tales from Colorado's western slope, from the mountains to the desert. Christi Reese and her team hear from the movers, shakers, and characters of the Grand Valley and surrounding mountain towns that make the western slope the place we all love. You'll learn, you'll laugh, you'll love with The Full Circle. Hi, everyone, and welcome back to the Full Circle Podcast. I'm your host, Christi Reese, and I'm really excited today to have a great conversation about the challenges we have with our soils and building homes here in the Grand Valley. And our guests are Mike Berry with Huddleston-Berry Engineering and Testing. Thanks for being here, Mike.
Thank you.
And Dave Hancock, the owner and operator of Porter Homes Construction.
Thanks for having us.
Thanks for being here. So let's start off with a little background on both of you. Dave, tell us a little bit about your construction history.
Sure. So, I started in the construction industry on the residential and commercial construction side a little over 5 years ago now. So still relatively new to this part of the industry. Before that, really all I knew was coal mining and oil field and the Army. So this is definitely my passion, and I look forward to learning everything I can.
Yeah. But you stepped into a position with a builder with a very strong reputation here in town.
Yes.
Porter Homes. How has Nate's transition over to you? What does that look like?
That's a good question. I would say that's kind of an ever-evolving door. Nate does a lot of land development stuff here in the Grand Valley. He's doing a great job with it. We got some good things coming. The big focus for me was taking over on the vertical construction side so we could really fine-tune a few things and make it to the next level. Mm-hmm. And so I'm happy to be here.
Yeah, great. And Mike, tell us a little bit about your background in engineering and soils.
Well, I've been doing this for almost 30 years now. I did undergraduate at the Colorado School of Mines. I grew up on the Front Range. Worked out east for a few years, learned quite a bit of what's going on out there. Went to grad school, and then moved my family back to Colorado. Ended up here on the western slope. I didn't really want to work in Denver. Yeah. So I've learned a lot since I've been here. I've been here for almost 20 years. Well, I guess a little over 20 years. Things have changed quite a bit. The soils, obviously, that we have out here are not optimal. I mean, every area has its challenges, but I think this area has some stuff that's special. I enjoy it. There's often things that still surprise me, even having been doing it this long. Mm-hmm. But yeah, it's really, really great to be here.
I know today we're going to focus on construction and what the soils mean for construction and housing, but what other kinds of things does your company do to help people investigate soils, and why?
So in addition to the building, whether it's commercial or residential construction, we do things like slope stability analysis, retaining wall designs, pretty much anything that has to do with soil or bedrock, geologic hazards. I'm sure most people listening to this have driven down toward Blue Mesa Reservoir, and you can see all the landslides.
Yeah.
Those soils are obviously a little different than what we deal with here in the Grand Valley, but there are some areas where those things come up. The big slide that happened last year, I think, 29 Road. So we do things with that, try to manage those risks and mitigate the risks associated with that. The bulk of what we do is new construction, commercial and residential, but we kind of handle all of the geologic and geotechnical risks.
For consumers, and are you consulting with government agencies as well?
We do some government work, not a whole lot. Most of it is either commercial, residential, or institutional. We do most of the work for CMU. We do work with the hospitals here, St. Mary's and Family Health West. We've done a lot for them. Government's its own special entity, and there's a lot of requirements in terms of hoops that you have to jump through. So we don't delve into that. There are some folks that do, but that's not really our strong suit.
And obviously there's public land that may have subsidence. Is that what you call the slumping?
No, that's would be a slumping.
Okay.
Slump
It is a
type
slumping.
failure. Yeah.
Okay. Obviously there's some public lands with issues like that, but when you're looking at somebody that wants to build or develop, the onus is on the builder developer to show the condition of the soils and then go to the government agencies and determine what needs to be done before they can develop and build, correct?
Yeah, on public lands, it would be the buyer. I'll use a good example would be Dos Rios here, just down the road. The city owned that land. They bought it from whomever owned it prior to that, and I don't think anybody was aware that it had been used as a landfill over the decades. Mm-hmm. And so we had to do a bunch of investigation to try to evaluate where those pockets of waste were and what we were going to do to try to mitigate the risk of settlement of new construction when the city decided to start selling off lots. And in fact, even one of the recent projects that's under construction across from the Starbucks encountered some waste that everybody had thought was no longer there. Uh-huh. And so obviously that creates complications with who's going to pay for that, and creates challenges for sure.
Mm-hmm. Dave, let's talk a little bit about how soil challenges can affect people's decision-making process when they're looking to build a home.
Yeah, so a good place to start is overall cost, right? If we have your typical standard custom home build, it's very important where they decide on purchasing a lot. Biggest reason being the soils, and that's why I rely on Mike and his team so much to help out with finding some of that. The overall cost, it could kind of change dramatically. You know, I'm not a structural engineer, so I can't necessarily design that, but we'll have a good idea of overall footprint of the home and what we'd kind of be looking at in terms of cost specifically to the budget. You know, right now, I think the last time I priced them out fairly recently is about $1,800 per micropile. You know, 30, 40, 50 foot depths. There's so much variation there.
Yeah.
And so I'd like to try to talk ahead of time with each client. If they haven't already purchased a lot, it's a little easier to help kind of navigate them to what already fits their budget. Mm-hmm. You know, when somebody comes to me and they say, hey, you know, we want to build a $1 million home, but it's not this multi-million-dollar project, you know, we have to very seriously consider what kind of parameters we have to stick within. We
have talked to clients about that. I know Kim Ferens, who works mm-hmm. with Porter Homes, yep. you know, has met some clients who say, we already have our lot and we want Porter to build us a house and here's our budget. And you think, well, when you bought the lot, were you aware that there were maybe some soil issues, and that's going to change your budget drastically, right? So
absolutely,
you're right. Having the conversation with the builder before you purchase is really smart.
It's helpful for sure. I've probably had over just even the last year, probably 4 or 5 different clients approach me before purchasing a lot, which was helpful. I actually kind of jumped through some hoops outside of, you know, the business hours on normal and tried to figure out, let's try to get a soils report done. If you can have a time frame before you go under contract and finalize this deal, let's figure out what it really looks like, because that can absolutely make or break a project for mm-hmm. somebody.
Question for you, Mike. Is there always a way to build on a piece of property? I mean, no matter yes. the soil conditions, you can build on it as long as you can afford.
That's right. That's the old engineering adage is we can do whatever you want. It's just a matter of what it's going to cost to do mm-hmm. it. And going back to what Dave was saying, having been in the Valley so long and having done this, I do have a lot of my clients. Nate's team has done it in the past, and some of my other builder clients, they'll call me ahead of time if they're in an area where there hasn't been a soils report done for the subdivision, and ask what my expectation is for that area, mm-hmm. If we've done other lots in that subdivision or whether or not. And it can make a difference on whether or not someone's willing to buy the lot. Mm-hmm. And of course, the economy of it. You get into the multi-million-dollar homes that Redlands Mesa, a lot of those, and those folks don't really care. They just want their house to not fall down, and cost is less of a consideration. Mm-hmm. But you start to get into the $500,000 mid-range house, and 60, 70 grand for micropiles becomes a massive issue. Mm-hmm. So,
as a realtor, sometimes when we're working with a buyer that's looking at lots, sometimes we'll go into a subdivision and the developer will say, we have soil reports for the entire subdivision, but not lot specific. And many times they're indicating that the soils are good. We don't need micropiles. There's no movement and things like that. But how important is it for people to have a site-specific report in that kind of situation?
Well, it really depends on where it is. There are certainly some areas kind of in the lower valley that the soils are pretty uniform. And the subdivision soils report, we've done a bunch of test holes and the soils are pretty consistent. Mm-hmm. It's not really necessary to do anything site-specific. The same applies to the northern parts of town when we start to get into the Mancos Shale. The shale's 2,000 feet thick, so it's pretty much all the same. But particular areas, Redlands Mesa, Spyglass, where there can be some significant variation depending on where exactly you're building in those particular subdivisions, it's very important to do site-specific. Mm-hmm. I mean, from a business standpoint, it would be great. I'd love to have everybody do site-specifics on every lot, yeah. But there are certainly some areas where it's not necessary.
Mm-hmm. From a builder's perspective, Dave, do you have that same attitude, like we can build anywhere? Or are there certain places where you say, I'd prefer not to build?
Yeah, that's a great question. We're not afraid to build anywhere in Grand Junction. The caveat being there is really the client's end-all budget. Mm-hmm. It really depends on what the end user gets at the end. And if you're spending almost $100,000 on micropile foundation work, that takes up a lot of what you're looking for your interior finish type of selections. From the builder perspective, I just want to kind of jump back to what Mike was saying. I prefer much more that we do site-specific soils examples there, mm-hmm. or samples. The reason for that is mainly my structural engineers, especially on soils for if we're in an AFT zone and we have to consider septic systems. Mm-hmm. That's very important for septic engineers to really figure out what that looks like, so we have a very clear understanding of what parameters we have to stay in and what that cost looks like. So I pretty much make it a standard that we're going to do a lot-specific soils report each time.
Good.
Well, that's a good point. The septics are a big deal. The regulations are ever changing. It seems like it's every other day. It's not, but that's kind of what it feels like when we are doing design work. But yeah, there's a lot of variation and a lot of things that we have to account for in the septic, and the same sort of cost increases can occur. I mean, it's not quite as dramatic as going from a spread footing to micropiles, but going from a conventional gravity-fed septic to a pressurized septic because of shallow groundwater or shallow bedrock, again, can double
you can
plus
add
the cost.
$5-6 grand pretty easy.
Yeah. Can you talk to us, Mike, about the different types of soil challenges that we have here in the Valley? I'm sure you could go really deep and technical on this, but what does the average consumer need to know and need to watch out for with the help of their realtor?
So to really narrow it down to the two primary problems, and that's collapsible soils and expansive soils or bedrock. Collapsible soils, the best analogy for them is a house of cards type of structure. Although you can't really tell from looking at them, but they have a lot of open void space. And if you introduce excess water or excessive load, you can get settlements that are well beyond what you would expect for a normal structure. They are not quite as dramatic as expansive soils. And the collapsible soils are kind of all of the, what I will call sheet wash deposits and the things kind of the north part of town, central part of the valley before you get to the Mancos Shale. Expansive soils are a completely different animal, and the best way to describe them, and so that it makes sense to people, is to think of a stack of cards. Clay particles are flat plates, and they have a negative charge on them. And water molecules are polar, so they have a slightly positive end and a slightly negative end. And what happens with expansive soils with the introduction of water is the positive charge on the water molecule is attracted to the negative charge of the clay, and the water molecule forces itself in between the plates. So think of it forcing the cards apart, and that's where swell comes from. The more expansive the material, the higher that negative charge is, and the more attraction it's going to have to the water. So the Mancos Shale, while it does have some expansion potential, we normally don't use micropiles. It's usually not necessary. The magnitude of expansion is lower than areas like Spyglass and Redlands Mesa, where we have Montmorillonite clays. In our lab, we have done testing on those materials, and we've had expansion pressures of 32,000 pounds per square feet, which is equivalent to 20 feet of solid sandstone. So What I'm saying is that you could have 20 feet of sandstone rock and a 6-inch layer of bentonite, and if that bentonite gets wet, it'll heave that whole thing.
Wow. And
so that's why the early houses in Redlands Mesa that were built before micropiles existed had problems because they hit hard rock and called it good, so to speak. So
a lot of people in the valley are familiar with bentonite. If you've hiked many areas in town after a rainstorm and gotten it on your shoes, you think, oh my God, this is the worst stuff ever. Is that the biggest culprit? Is the bentonite, or is there another substance that is?
No, yeah, it's definitely the bentonite. The bentonite is a Montmorillonite clay. I mean, there's different names for it, but yeah, it's the bentonite. And so it's primarily in the Morrison Formation, which is all of the stuff that comprises Spyglass Ridge and the ridges in Redlands Mesa, and that whole area kind of south of Broadway and some areas a little bit north of Broadway is really where that geologic unit exists, and we have to concern ourselves with those materials. Now, the really important factor from a homeowner standpoint, people that might be listening to this podcast, is water management. Expansive materials don't expand, and collapsible materials don't collapse in the absence of excess water. And so...
But so is average rainfall, can that be considered excess water? I mean, do you need to mitigate rainfall or just what you're putting on the property?
Rainfall on the roof, so we'll call roof runoff, is critical. I mean, you take a 2,500 square foot house and we get one of our 2 or 3/10 of an inch rainstorms, you get a lot of water concentrated in the downspouts. And the most common problem that I've seen over the years is in these areas where we're building expensive homes in these materials, the homeowners don't want to see the downspouts, so they're all buried. And they either get a separation of a joint or there's a leak, and nobody sees it until it's far too late. All that water is concentrated in the downspouts and gets right up against the foundation and creates these problems. And so I would say 80% of the projects I've been involved in that where expansion's been an issue, it's been the downspouts. That's not to say that there aren't situations with irrigation. Here in the valley, irrigation water is cheap.
Yep. And
so everybody, including myself, overwaters.
Tend to overuse,
But the key is keeping bushes and things away from the house and not watering those with automatic systems. We had a project where years ago the house had, I think, 9 inches of total movement, and it turns out it was just a leak in one of the transmission pipes or the side pipes. I think a 3/4 inch pipe had a small leak in it. Not enough that it would bubble up at the surface, but it had leaked for 3 or 4 years, and the house moved
9 inches.
9 inches.
That's a bit.
Yeah.
Dave, talk about the different ways that you address soil challenges. And we used to use a term pylons, and that's not a technique that's used anymore, or was that ever a technique that was used for swelling or collapsible soils?
Yeah, I'm sure it was. I personally don't have much experience on the pylon side. And geographically, it kind of depends on where you're at. Without the United States, we see a lot of stuff on the East Coast done quite a bit differently than out here in Western Colorado. Most of the time, again, in my experience, it's been micropile type of foundation work.
Can you describe what a micropile is and how it functions?
Sure. So based off of a soils report and the structural design of the foundation, then we have load calculations. Again, this is his area, load calcs, structurals. But once we know what those load calculations look like, then we can basically take a foundation plan and figure out how many micropiles is this specific site going to require to have the most stable foundation. And so to give you an example, Redlands Mesa, we've done, quite a few homes up there. I've got one coming pretty soon, I believe. We've got over 100 micropiles on it. So it's a big expense. Again, we have to consider. Now, I would say, well, let's go into the micropiles themselves. So once it's designed by an engineer, then we go back onto the job site. Excavation happens first. And a lot of times in Spyglass or Redlands Mesa, this comes in stages. So some excavation has to take place first. We come in with the drill, and then the drill crew will drill out our pilings to those specified depths of the engineered plan. A lot of times, I think the average is probably 30 to 35 feet, most commonly.
So you're getting through that top layer of tricky soil and getting down into the Manco Shale or some other
Well, what you're
layer.
trying to do really is get the bottom of the pile at a depth that is past where we expect water can penetrate. And so the micropile, if you do get swelling, the intent is that the micropile will essentially hold the structure down.
Okay.
Based off of friction. We call it skin friction, right? Correct. Skin friction. So when we drill the micropile out, it's a small diameter. You drill in the casing, and then we insert a threaded rod in most cases. I believe most commonly it's about 1.75 inches. So it's relatively small. The threaded rod is then inserted into the casing at depth. And then as we're pulling out the casing, you're filling the hole with grout. So the grout helps with the skin friction against the rod and the earth movement. So the whole point would be to, let's say we have collapsible or expansive soils to a depth of 20 feet. Most commonly we're going to see a drilled piling down to 30, 35. To meet the soil that's going to resist the water, obviously we want to get away from it completely as much as possible. Groundwater can be an issue, so that's kind of the overall goal intent.
So is it correct? Sometimes people have talked about like floating foundations. Would you say that that's what the micropiles provide?
I would say in a sense, because they're adjustable,
Mm-hmm.
but I wouldn't, it's not like a floating floor system, right? It doesn't just continually expand and contract. There is some movement there that over a couple years you may make some adjustments in the foundation on the micropiles themselves, but I personally struggle with calling it a floating foundation system, but I have heard it called that quite a bit.
One of the things that we deal with as realtors a lot is people have heard that there's some soil issues in the valley, and they'll go into a home, whether it be new or old, and see a crack in a wall and think, no, I'm out.
Yeah.
All houses settle. Is that true?
Yes.
Mm-hmm. And how would you advise a homeowner to look at a crack in a wall? Like, what is concerning and what is not?
Well, that's a good question. If it's a simple crack in the sheetrock, there's multiple things that it could be. Obviously, the biggest issue that you're going to want to consider looking into is the foundation. There's been homes built over, the 50s, 60s, and 70s, some in the 90s, early 2000s, where this wasn't a big thing and it wasn't done. So if you find a crack in your sheetrock, if it's on a crawl space, I'd be going to the crawl space just to check some things out. Make sure it's not a bigger problem than what it really could be. So,
the one thing I'd point out is that there's the big difference between settlement and expansion is settlement's a finite process. The soils can only compress so much. And so while most structures will settle a little bit over time, usually it will stop once it's reached equilibrium with the weight of the structure. Swelling, on the other hand, particularly with the bentonite, their affinity for water is such that they can consume mass quantities of water. And so as long as there is introduction of water, the swelling, it's not infinite, but it can go on for years, decades, whereas settlement stops.
Interesting.
Yeah.
Yeah.
When you talk about homeowners looking at a house, older structures, and that's what I often tell people, is if it's an older structure and there's some cracking, it's probably from movement that happened long ago. Maybe not in Redlands Mesa, but most places here in the valley, lower valley, if we've got cracks, it's probably from something that happened decades ago, just was never fixed. Of course, we also have in this area extremes. It was 2 below at my house the other day, and then we get 100 degrees in the summer. And the expansion and contraction of the building materials just from the variation in temperature, the wide swings can cause cracking. But it is hard to, particularly from your standpoint, try to convince somebody that it's not a big deal when people hear horror stories of...
Well, and we're not foundation experts. We see certain things that concern us, when you're looking at doors and windows that don't close, you can sometimes go in a house and feel that things are off kilter, or, there's some window and door frames or cracks that aren't uniform or straight. You can see when there's a crack on a sheetrock seam, you think, well, no big deal, but coming off the corner of a door or something. So we always recommend an engineer take a look. We want people to have all the information they need to make an informed decision. But I think some people really get scared about some things that maybe are fixable or not a non-issue.
Yeah, I think a lot of the scared feelings of these types of foundation issues that we come across are really, it boils down to not knowing anything about it. You hear a horror story from somebody that bought a house in Redlands Mesa, and maybe they told their friend who's looking to build a home. So I think it's extremely important. I take a lot of time with each of my clients to really boil down what it looks like and make sure they understand what this could potentially do to a project budget. Again, that comes back down to cost. It's a big expense. So, yeah.
But the micropiles, the introduction of micropiles was really a game changer. You refer to pilings, drilled piers is what we'd call them, and they're not that much different than micropiles other than their larger diameter. But the drilling equipment's different. And so in the 70s, 80s, 90s, even early 2000s, in these areas, they would start to drill a hole, and when they hit hard rock, they would stop because they couldn't advance into the bedrock. And so they oftentimes were not getting these piers to a depth that was below the moisture change. A great example is, I don't know if you knew Dutch Affman. His house was kind of the poster child for
on the corner up there,
across from the golf club.
Yep.
His house was on drilled piers, and they just weren't deep enough, and so everything moved. And I think we did several floor level surveys as expert witness for him in his lawsuit, but I think we had 14 inches of movement in some areas of the house. I mean, it was
significant.
fast forward to 2008 when micropiles became available. At the time, Maze was the only folks doing it. And we did the house immediately next door, which covers 2 lots, giant expansive house, and I've never had a call from the owner saying that it's ever moved. Micropiles are about as bulletproof a foundation as we have. There have been houses that have moved a little bit, and generally what happens in those cases is the soil in between the micropiles starts to push up against the foundation wall, which causes flexure of the concrete, if you can believe that. It can flex more than you would think. But if you go in and reestablish that void space underneath the concrete, it goes back to where it was. I mean, the micropiles are really, like I said, they're as close, from an engineering standpoint, they're as close to 100% success rate as anything we've ever had.
Good insurance to have.
Yeah. Well, I was going to ask a little bit about repairs, because obviously neither one of you own a foundation repair company, and that may be something that you don't want to address so much. But for people that have experienced movement in their house that have cracking or unevenness, there are ways to fix those problems.
There are. The problem is they're very expensive. So let's say you've got $60,000 to put micropiles under a new house, just to throw out a number. For that same house to try to put micropiles in 5 years later after the fact, you're probably at least double that cost. What I recommend to most of my clients is, if they think they're having movement and we can demonstrate, we do floor level surveys and we can demonstrate that yes, there has been some movement and it's actively occurring, find the source of the water, stop the water, and then in most cases you do that and the structure will reach an equilibrium point to where it's not moving anymore. And then you can decide whether you can live with that or you really want to try to repair it. But in most cases, folks will go in and they'll reset the door jambs and they'll do those things that cost them $10,000, $20,000 and just move on with their lives.
So the movement is always water related, always?
I hate to say always. As an engineer, we never say always.
Yeah.
My lawyer tells me never to say always. The vast majority of the time, particularly here in the Valley, it is water related. Now, I'm sure there are cases, I haven't run into any, but I'm sure there are cases where somebody did a bad design and overloaded the soils. They used too large of a bearing capacity, and so the foundations weren't spreading the load enough, and they got excess movement. So there can be movements from failures either with engineering or construction, but the vast majority, I'd say 95+% of movements that we see here in the Valley are because water coming from somewhere got into the system.
Water management is a really heavy conversation that we have with every client. There's so many things that we can do to try to mitigate what that could look like again, it's good insurance, right? If we have certain areas of the Valley too where we maybe don't have to have a micropile foundation, Mike will say over excavate X amount of feet, import some structural fill, we'll get it to compaction, make that proctor. The bigger portion of that question is, once I backfill, I'm gonna install a foundation drain all the way around the house. We've had a couple other projects where a larger lot, we were concerned with overall drainage towards the house, and so we've cut swales in to really redirect the water all the way around the lot. And I'm doing a house right now actually where it's kind of a tricky lot to get into, and it's quite a ways from the street, probably 60, 70 feet. So that doesn't leave me a whole lot of room for concrete work. We ended up building concrete retaining walls and foundation drains around the entire lot to try to manage the water correctly. And it sounded like that was a tricky situation with the previous owner of this land who wanted to build out there. So again, certain things, it's, would you prefer to spend $100,000 or however many thousands of dollars on micropiles, or can we come up with a different solution? Cost analysis is a big deal for it. So,
would you agree that even if you've got what we would call good soils and a lot of irrigation water, always best to keep the water away from the house?
100%.
Right? Like a lot of people would like to have beautiful landscaping right up to the edge of the house, but the smart move is to just keep it away and keep the water directed away from the foundation.
Absolutely. And we see a lot of people who are building now, take Soaring Eagle, for instance. We're looking more for a lock and leave kind of turnkey scenario out there. Most people don't want a whole lot of maintenance requirements. And so we're starting to get away from, back in the day, we put shrubbery and trees right against the house, and now everybody's more xeriscape or closely around, and you have a little more room to wiggle with that. So certainly the most important thing.
You mentioned a little bit earlier about water table. How does that play into house building and designing of foundations? And
well, there's several issues. I mentioned before the septic. That's always a problem if we're on a lot that has septic. The regulations require that the bottom of the leach field be 4 feet above the water. And unfortunately, we're bound by that. It's a state regulation, and it's essentially a groundwater drinking regulation. There are still people in the Front Range that have shallow wells and actually drink from them. I would caution anybody against drinking the shallow water here in the Grand Valley. I think you will have major issues. But the other problem, or one of the other problems, is water in the crawl space, depending on seasonal variations. And I have seen not many areas here in the valley, but there are some areas where you'll get 4 to 6 feet of groundwater elevation change between the irrigation season and the non-irrigation season. And so, again, we can use perimeter foundation drain. We can use a different type of foundation. Oftentimes, those are areas where we'll use a slab foundation, just so we don't have to worry about water in the crawl space. But from a constructability and cost standpoint, from the construction side of things, when we have shallow groundwater, we often also have really soft soils. And so the builder then has to come in and they have to put in a bunch of geogrid and pit run, and the costs can escalate out of control very quickly, just to make the ground firm enough to pour the foundation on. We don't see it as much in residential, but here commercial, just about everything here in the downtown area and lower valley, we have those soft soil problems that we deal with during construction.
Some of the older houses downtown, getting water in the basement, have sump pumps and things like that. That's because of the groundwater.
And the groundwater's come up over, some of those houses are World War II, post-World War II age. And most of the groundwater here in the valley, with the exception of down by the river, is due to the 100-some years of irrigation. The north part of town probably had to go 100 feet to find water 100 years ago. And so all that irrigation water flows toward the river, and over time, over the last 50, 60 years, the water's come up everywhere, several feet. And so, you have some of those older houses that never had a problem for 50 years, and now all of a sudden they're getting water in their basement, and it can be a significant issue to deal with.
You mentioned Soaring Eagle, Dave. Great subdivision out there in the Redlands. What are the soils like out there?
Soils out there have been great. We've been able to use the majority. We would over-excavate X amount per the engineer recommendation. Most often it's about 2 feet over excavation. We then process that fill, and we use it as, instead of having additional cost in structural imported fill, we can use the native so long as we get to the 95% Proctor compaction rating. So, while that is a little more costly in terms of overall labor to get the work done, depending on the size of the home, obviously, certainly cheaper than having to import structural fill. We do that sometimes, just as, again, as safety, it's easy insurance. If a client doesn't mind paying for that and they have peace of mind with it, I'm not going to tell them no.
Right.
We're actually getting ready to do one out there in that exact same scenario. So we don't have to, but we're going to.
And when I think about the redlands and the water that comes off the rocks and the alluvial plains, are there, obviously in some areas you can see the bentonite, in some areas the redlands, and it's very obvious, but are there other visual indicators of where you might find challenging soils?
Not usually. Quite frankly, most of my knowledge is just having poked so many holes and pits over the years. We have drilled lots in Redlands Mesa where we've done our borings and we haven't hit a lick of bentonite. But I'm still going to put it on micropiles because the bentonite is not generally a continuous layer. Like the Mancos Shale is just shale upon shale upon shale. But the Morrison Formation, you can have little pockets of bentonite. And so just knowing that it's there, even though we don't see it oftentimes.
Mm-hmm. Yeah, you know where the pockets are.
Yeah. I'm sure they're there. And again, you're talking about $1 million house plus up there, and it just doesn't make sense to not do micropiles. And maybe you find a lot, and maybe there isn't any bentonite, but that's a big roll of the dice.
Big risk,
given all the things that have happened up there over the years.
Yeah. Well, this is a fascinating conversation, and I've learned a lot. I've been selling real estate in the Valley for over about 23 years, and come across a lot of different conditions. But it's we always direct people to the professionals, the builders and the engineers. Like we know a few things to look for, but we don't want to hold ourselves out there to know these kind of things. So it's great to have this information, and I hope that I know that my agents will refer to this video, but also hopefully the public can look and gain some information from it and help them with their home building and repair choices in the future. So,
well, and I would say that if somebody's looking to buy a home here in the Valley and their realtor and or builder, or they're going to build a house, doesn't suggest that they, talk to an engineer or doesn't provide them with some information, that's a big red flag.
Yeah. No matter where in the Valley.
No matter where in the Valley.
Yeah.
I think it's really important that people be aware. You don't want to scare people off, but most of these risks can be managed. We've been doing it for a long time, and it's important that they know the magnitude of the risk. Are we talking about a substantial problem, or maybe not so much? And the builders and realtors really need to be providing that information to the buyers.
Absolutely.
Yeah, it's part of the due diligence that you need to be taken care of on your own. We have conversations with a lot of different folks. Some I haven't even gotten the opportunity to build for yet, just simply because we haven't found the right opportunity on a lot. And if I don't have the right guy to do the job and figure out, on timing and where it's at, then we'll get the right person to do it. But it's extremely important to consider that, especially when most people are on a fixed budget for the certain parameters they're on for a project. Mm-hmm. Yeah.
Awesome. Well, thank you so much for your time today, and this is great information. Mike Berry with Huddleston-Berry Engineering, Dave Hancock with Porter Homes. Reach out to these guys if you have questions about building a home, about engineering, about soils. They're a wealth of information, and I appreciate you both very much.
Thank you so much for having us.
Thank you for having us.
Yeah.
It's been a lot of fun.
Good. Thank you. All right, everybody. We'll see you next time on the Full Circle Podcast. Have a great day. Bye. Thanks for listening. This is Christi Reese signing out from the Full Circle Podcast.